Hello everyone, good day. Today I'm going to teach you how to illustrate polynomial functions, identifying polynomial functions and those who are not, which are not polynomial functions, and also I'm going to teach you how to solve the values of x roots solutions or zeros of polynomial functions. I hope you have your calculator or like this so that it can help you to solve it out, and then also enjoy watching this video and I hope you learned something out of it. Once again, this is Sir Jemson, and of course easy math for you. Keep watching. Today I'm gonna teach you how to illustrate polynomial functions, identify polynomial functions, and solve the roots for values of x of polynomial functions. We all know what polynomial functions is, right? So let's just do a review, sort of review here. We have names of polynomial functions according to its degree, and we'll be having some sort of examples in every name. First function is what we call constant. Okay, that's constant function, and the degree of that is 0. Example for that is fx is equal to 2, or fx is equal to 3, or any kind of number as long as there is no variable and that is totally a constant number. Okay, and of course if you can see functions like this, the degree of that or the highest exponent is 0. You have to remember that all the time. Okay, so for another name is we have linear. Okay, you have learned already about this during your earlier years, right? The degree of this or the highest exponent is 1, right? For example, for that is fx is equal to 2x plus 1, or you have h of x is equal to 3x, right? The degree is 1, the degree is 1. So the highest exponent is 1. Okay? So you have to see that. Next is we have, of course, quadratic functions during your grade 9 level. The degree of that is 2, and example of that is you have y is equal to 2x squared minus 4x plus 1. As long as you can see a highest exponent of 2, then that is automatically a quadratic function. Okay, for number 4 you have cubic function that is in a degree of 3, and for example for that, if you have negative 3x cubed plus 2x squared plus 4x minus 1 and so on and so forth, as long as the highest exponent is 3, and that is cubic function. Okay, next we have quartic function. The degree of that or the highest exponent is 4. You can see it. You have, for example, you have fx is equal to negative 1/2 x raised to the 4th power plus x cubed minus 5, and so on and so forth, as long as you can see the exponent or the highest exponent is 4 over the other's exponent. Okay, and that is for quartic. And for number 6 we have kinetic function. Okay, that is a degree of 5. Okay, example for that is square root of 7 x raised to the 5th power. Okay, it doesn't matter what kind of number is this, as long as it is real, not undefined. The most important there is the exponent. Okay, minus 4x plus 1. As long as you can see the exponent 5, that is automatically a kinetic function. Number 7, we have polynomial function. Okay, polynomial function in a degree of 6, and so on and so forth. Doesn't matter, as long it matters in the number of degree, as long as it's bn 6, 7, 8. That the name of that is polynomial function in a degree of 6 and a degree of 7. Example for that is f(x) is equal to negative 4x raised to 7 or 6, plus, as long as you are seeing that 6, you are seeing that 7, that is polynomial function in a degree of 7, and so on and so forth. The most important thing to remember to this, actually these are all polynomial functions. What matters here in every degree there is a specific name for that, and it has a specific example. Okay, you have to be careful in determining that. Okay, so that is how you are going to identify polynomial functions. Okay, let's try examples of that. Example number 1, if you have fx is equal to square root of x plus 1, what do you think? Is it a good polynomial function or not? If you're going to identify this one or as polynomial function, you need to test first. Okay, you need to to comply some requirements. Remember, class, that this one, if we are going to convert that one, that is a radical expression. If we go to convert that one into a rational exponent, that is going to be x raised to 1/2, and that's going to be x plus 1. Okay, so if you can see it, you have exponent of fraction, and that is not a whole number. Okay, so automatically, if you are seeing exponents like this, automatically a certain function is not a polynomial. Okay, so for example, this is not a polynomial function. For example, you have x square root of 7, this is not polynomial function. For example, you have x 0.03, that's not polynomial function. X raised to -4, that's not a polynomial function. The polynomial, the only thing that you will remember in polynomial function, the exponent is always a whole number starting from 0 above. No negative, no radicals, no fraction, no other than, aside from whole numbers or counting numbers. Okay, let's have another example to implore or to push your mastery about the problem. Okay, about polynomial function. What if we have example like 2x cubed, and that is gonna be fx, that's function of x, and then x plus 1 squared. Okay, without solving the one, that is polynomial function. Okay, you have an exponent of 3, you have exponent of 2, and that's not a fraction nor decimal number or a radical fraction or radical expression or whatever. These exponents are whole number. Automatically, this is polynomial function. But if you're going to get the degree of this, just very easy to get the degree of that. You're just going to add it up. This is gonna be 2, and this is gonna be 3, and the degree is going to be 5. Okay, just add the exponents. Okay, because you are multiplying here. So the degree is 5. If the degree is 5, therefore that is a what we call kinetic function, right? It is a polynomial, a special type of polynomial function named as kinetic function. Okay, so let's have more example. For example, you have an example of x squared plus x plus 1 over x plus 1. So if you can see it, you have exponent of 2, you have 1. However, you have this one. 1 over x is just the same as writing x raised to -1, because x raised to -1, this is the reciprocal of it. And if you can see it, you have a negative exponents. Okay, the -1. Therefore, this is not a polynomial function. Remember that all the time. The requirement is all terms have exponent of whole number starting from 0 above. No negative, no fraction, no decimal number in the exponent part of the expression. Okay, so in this example, this is not a polynomial function. Take note of it. Okay, for the last example, so that we can proceed on how to find the roots or values of the x of polynomial functions. So for example, you have, this is gonna be the last example. If you have f, or let's gonna use another variable, h of x is equal to square root of 5, and then the variable is outside, it's gonna be 2, and then minus 1/2 x, and then it's gonna be plus 4. If you can see it, the coefficients are in the form of radical and in the form of fraction. Does it matter? Does it have bearing upon identifying if it is polynomial function or not? Does it has a factor? Actually, this is a polynomial function. This is a polynomial function with exponent or highest degrees of 2, and therefore that is a quadratic polynomial function. Okay, so why, sir? Why? You said earlier that if there is a quadratic and there is a radical, fraction, decimal, and so on and so forth aside from whole number, it will not be a polynomial function. What I'm saying earlier is all about the exponents. Okay, the exponents here. If you can see it here, the exponents are 2 and 1 and 0, and there is no such radical and fraction form. Okay, regarding to the coefficient, it doesn't matter as long as it is real number. Real number comprises radical, fraction, decimal, and so on and so forth. As long as these are real numbers here in the coefficient, it will not affect your function. It will still be polynomial function as long as the exponents are in a whole number, and that's how you will identify that. Remember that all the time. So at this point of time, I'm going to teach you how to solve the roots or values of x of polynomial functions. Okay, alright, for example, you have a polynomial functions of this. I'm gonna put this as in a factored form already, because this will be very useful in graphing. Okay, so for example number 1, if you have a polynomial functions of x, and it's gonna be x plus 1 and then x minus 3, that is already in a factored form. We don't need to expand that one, because I'm giving you examples of polynomial functions in a factored form, so that you can easily graph it out in the Cartesian plane for the next video. Okay, so here, this is a polynomial function. We have some steps, okay, these to consider. Okay, first thing to do is you need to find about the roots. Okay, the roots and the value or the values of x of this certain polynomial function, and we're gonna identify the degree of it. Okay, the degree or the highest exponent. Okay, first thing to do is, this is just very easy. You are just going to segregate all the factored form like this. Okay, so, and after that you're gonna equate this by 0. This is gonna be x is equal to 0, x plus 1 is equal to 0, x minus 3 is equal to 0. As easy as that. Of course, the first value of your x is 0, and this one, of course, that's very easy. In your remainder theorem and factor theorem, it's gonna be -1, and this one is gonna be +3. Therefore, your roots now here is you have 0, you have -1, and you have +3. These are now your roots. Now, the next question is, how are you going to determine the degree or the highest exponent? Just simply counting the number of roots, you will identify the degree of the exponent or the degree of the function. So the degree of this function is 3. Why? If you count it up, 1, 2, 3, you have only 3 roots, therefore you have 3. Or if you are going to look in the given function, you have 1 there, you have exponent 1 here, 1 here, so 1 plus 1 plus 1 is gonna be 3. Therefore, you have a degree of 3, and of course, the number of your degree is just the same as the number of yours. If you can see it, your degree is 3, therefore you have 3 roots also, because there is a connection between the degree or the highest exponent of certain polynomial function and its number of roots. Okay, so that's it. So for example number 2, for example, you have g of x function, and it's gonna be x squared, and it's gonna be x plus 3 and x minus 4, and yeah, like that. If you have function like that, okay. So the same, you are going to equate that by 0, and it's gonna be to find the value of x, it's gonna be 0, of course, and then next is this one, x plus 3 is equal to 0. This is going to be -3, and the other one is that's 1, it's going to be +4. Now, if you can see it, be careful with it here. You have the roots of 0, however, you have a multiplicity of it. What do you mean by multiplicity? It is repeated 2 times, therefore 0 multiplicity of 2. If you can see it, you have 2 value of x here, okay? And the exponent of that is 2, therefore the meaning of that, you have root of 0, however it is in a multiplicity of 2 because it is repeated 2 times. Okay, so take note of that. It has exponent. The other one is you have negative 3. You don't have multiplicity for that because you have only one here. And the other one is you have positive 4. And if you can see it now, these are now your roots. You really need to write multiplicity if there is a certain exponent in a certain root. Okay, remember that all the time. Therefore, our degree here, just simply counting here, 2 plus 1 plus 1, that's gonna be 4. Okay, and also here you have 2 zeros, 2, 3, and 4. Therefore, the degree is 4, and your roots is 0, multiplicity of 2, negative 3, and positive 4. And that's how you're going to solve the roots and determining the degree of the certain polynomial function. Let's go and explore more examples. So if you have example like you have h of x, and it's gonna be x, and it's gonna be x minus 1 squared, and you have x plus 3 squared, and you have x minus 1, no, x plus 1, like that. How will you find the roots to that? So first, of course, that's gonna be 0. The other one, that is positive 1, of course, it's gonna be positive 1, that's negative. And the other one is gonna be negative 3, because that's positive. And the other one is gonna be negative 1. If you can see it, look always to the exponent. So the roots now is 0. We don't have multiplicity for that. The other one is 1. Okay, multiplicity, you gotta write that 1 all the time. Remember that. Multiplicity of 2, because it is repeated 2 times. The other one is negative 3, multiplicity also. Yeah, multiplicity of 2. Okay, you can see it, it is repeated 2 times. And the other one, we have negative 1. So these are now your roots. 0, 1 multiplicity of 2, negative 3 multiplicity of 2, and you have negative 1. Now, how will you identify the number of degree? Of course, by simply counting. You have 1 here. 1 plus 2 is 3, plus 2 is 5, plus 1 is, it's gonna be 6. Therefore, the degree is 6. Yeah, as easy as that. I hope you learned something about how to illustrate polynomial functions, identify polynomial functions, and solving the roots of polynomial functions using its factor form. Thank you for watching. I hope you learned something.
Dang, who knew? All the planes we flew, good things we've been through. I'll be standing right here talking to you about another path. I know we love